Alright, so let's talk about a real problem you hit when you give an LLM access to APIs: token bloat. An API response can be huge, hundreds of fields, deeply nested JSON. If you dump all of that back into the conversation as a tool message, you're burning tokens, you risk hitting context limits, and the LLM has to sift through noise to find what it actually needs. That gets expensive really fast. So the API call tool has two built-in strategies to keep things clean. Now, first one is response fields. When the LLM calls the API, it can pass a list of field names or dotted paths like name or profile.address.city. The tool makes the HTTP call, gets the full JSON back, then walks through it recursively and pulls only the matching fields. Everything else gets thrown away before it ever enters the conversation. This is great for simple flat extractions. Now, the second one, which is extraction script, is more powerful. The LLM writes a small Python snippet at call time. The snippet receives the full parsed JSON as a variable called response, does whatever logic it needs, filtering a list, mapping fields, pulling nested values, and assigns the result. So if we go to run extraction script over here, we can see that the script runs in a sandbox environment, no imports, no file IO, no network access, just safe built-ins like len, sorted, filter, and it runs on a separate thread with a hard 5-second timeout. So a batch script can't hang the system. That's the whole point of the 5-second timeout. All right, so if we look at the truncate text part, let's look for that. All right, yeah, this one. So as a final safety net, everything, whatever it's extracted or not, gets passed through truncate text. All right, so which caps the output at like 12,000. I think it's 12,000. Let me check that again. Yeah, so it caps it at 12,000. So 12,000 characters. So the tool message that goes back into the conversation is always small and focused. The full API response never enters the message history. The LLM decides what it needs at call time, the tool strips everything else, and only the relevant data flows back into the graph. Now, if we, a few other things I would like to point out is in config.py. So, two more quick decisions worth mentioning. Auth is handled via Python's ContextVars, as you can see, and tokens are set par request by the calling layer and read by the API tool. No global mutable state, safe for concurrent requests. And another thing is, if we go to the agent.py, we'll see that Postgres does everything: vectors, conversation checkpoints, and the application database. One infrastructure dependency and pgvector. So we are using pgvector for embeddings, LangGraph's PostgresSaver for conversation memory. Those two things are worth noting. And yeah, that's pretty much it. That's pretty much it. Yeah.